All right. So we are going to do just 3 examples today. We're going to do some stuff that you kind of already know. We're going to get used to using the Pythagorean identities again. We're going to use the even-odd identities. We're going to take this nice and gentle. I'm going to try to be as gentle as I can throughout this chapter because I know this chapter frightens everybody, especially the way I've built it up my bed. So this is 7.1. Fundamental identities. This is basically like how to use these fundamental identities, these ones that we've been talking about. And today is 12.8. Okay. So, if tangent of theta equals negative 5/3 and theta is in quadrant 2, find secant of theta. Okay, so if we look at our unit circle right now, can you guys tell me, am I going to find any tangents that are 5/3, negative 5/3? No, I don't think there's a 5 on this entire thing, is there? For x's and y's. Is it possible to have a tangent that's negative 5/3 though? For sure, it's just not like one of these specific angles, but it's something. All right, so we've got to figure out a way to go from tangent to secant, and spoiler alert, we're going to use these Pythagorean identities a lot. Anybody have a good idea of what we should do? Tangent squared plus 1 equals secant squared. All right, I'm going to write that down. Tangent squared plus 1 equals secant squared. How did you know that we were going to use this one? Because there's tangent in it. And we're trying to get to secant, right? That's nice. It's going to go from tangent to secant. What if we weren't trying to find secant? Would it still help to use this one? Yes, because then you might be, once you have secant, you can get cosine, right? Because cosine is just the inverse of it, and then you can easily go from cosine to sine. You can get all of them if you want to. Do we have to get all of them? No, we only have to get secant. Okay. So what should I do next? Plug it in. Notice that when I plug it in, guys, I don't have a theta left. Tangent theta is negative 5/3. So let's see, that would be what, 25/9? I'm going to make this 9/9. Do you guys understand why? What's 25 plus 9? 34. 34/9 is equal to secant squared theta. What should we do now to get secant theta by itself? And square root. I love that like 3 of you at the exact same moment in time did this. Like, you know, one of those. Do you guys remember what you do if you take a square root of something always? If you do a square root, what do you always have to do when you're solving a problem? Well, I mean, yeah, but there's a special thing with square roots. Anybody remember?
Oh, the one with the square.
Like you have to take the square root of the top right one?
Yeah, not really, but that is true. I mean, you're right about that, Emma.
You gotta account for the, like the negative 3 or the 3.
Right, like if it was a square root of 9, it would be 3 and negative 3, right? That plus or minus. Do you guys remember that? Plus or minus? All right, so I'm going to write out, so this is the square root of 34, and like Sierra said, we do have to do the square root of the top and the bottom. Is the square root of 34 reducible? What goes into 34? 2 and 17. 17 is prime. Okay? So what's the square root of 9 on the bottom? 3. And I'm going to put a big plus or minus in front of this equals secant of theta. But now we've got to decide, is secant theta supposed to be positive or negative right now? It's in the second quadrant, and what is secant? Do you guys remember what that's the opposite of? Is it the opposite of cosine or sine? Cosine. Is cosine positive or negative in the second quadrant? Negative. So the answer is going to be negative. So my final answer is negative. The square root of 34 over 3 equals secant theta. Okay, so we did something very much like this like a chapter ago before this chapter is coming back. Hopefully now it feels almost like a walk in the park a little bit compared to before. Anybody having a little bit of a panic attack right now? We all good?
Could you go over that like plus or minus thing again?
Sure.
That you did?
So, secant is the opposite of cosine, so whatever's happening to cosine is what's happening to secant.
Okay.
Do you understand that?
Maybe.
Okay, so if you look here at secant, do you remember how secant is 1 over x?
Yep.
And cosine is x. So like if x was a negative 5, then secant would also be negative.
Yeah.
And if cosine was a positive 5, secant would also be positive. So then it says here that it's in quadrant 2. So cosine in quadrant 2 is negative, so I know secant's negative.
Yep.
Okay, thank you for asking. Example 2, we're gonna do 3 examples, they're gonna get progressively harder. All right, same thing, only this time we're gonna find sine of theta. I'm gonna give somebody a prize for this who's willing to try to talk it with me live, okay? That means I'm not gonna give you a chance to work on it by yourself. I want you to just try it with me, but you teach me how to do it. Okay, now it's the exact same thing. It's the exact same thing here. We still have that tangent of theta is negative 5/3. We already found out what secant is. So now we know secant and we know tangent, but we need to find sine. So my question is, where do we go from here and how do we do this? Anybody willing to just take a chance? Take a chance. What happens if you get it wrong? Nothing. 1, 2, 3, 4, 5, 6. Did you drop your hand right before I gave you a number? Do you want it to be in or no? Okay. 6.
Okay.
Look, I promise.
Okay.
Okay.
So, since you know what secant is,
Mm-hmm.
you can do the opposite of that, because then that would be,
You mean like flipping it?
yeah, flip it,
Okay. To find what?
cosine.
All right, so I'm going to write cosine of theta equals negative 3 over the square root of 34. I agree with you so far. I'll stop you if you make a mistake.
And then you have to get the square root out of the bottom,
Mm-hmm.
so then it'd be times the square root of 34 over the square root of 34.
Mm-hmm.
Which would just be negative 3, and the square root of 34 on the top, and just 34.
Okay, I agree. And this is very helpful, and we will need it, but that's not the answer, right? So now, how do we find out sine?
So then you do that first equation on the Pythagorean identities, so sine squared theta plus cosine squared theta equals 1.
Right. Do you see how what Emma's doing right now? You have to make a plan in your head, kind of like where you're going before you go there. So you have to go, okay, I'm going to use this formula to get to this thing, and then I'm going to use a second formula to get to this thing. Does that make sense? And that we weren't doing that before. Yeah?
So, we already have secant and tangent, so why couldn't we just use the second equation instead of doing that?
This equation?
Yeah,
Because we're trying to find sine, and sine isn't in that
Oh.
equation.
right.
Okay. All right. So now you said we're going to use, I'm going to write this really slow.